So one of the things I want to make sure we talk about is that one of the major driving forces behind the plates is convection currents. Now, by definition, convection is the transfer of thermal energy. But that's not what I want to hear from you guys when I ask you how does convection work. So I say, explain the convection cycle, and do not give me the definition, the transfer of thermal energy. That's not what I'm asking for. So, how does convection work?
Convection, like, it's not really like friction.
Okay. Right.
It's running.
Nope. How does convection work? Talk about before this, guys.
Is it where heat rises up and the air cools off, and as it cools off, it lowers and releases hot air?
That's exactly what it is. Okay. So we get heated near the core, the material starts to rise up towards the surface. As it rises to the surface, it starts to cool down because it gets away from the heat source. When it cools down, it becomes more dense, it condenses. And then it falls back toward the heat source. It gets heated up and it rises back up again. So it's this constant repetitive cycle. But now let me ask you something. If you were to follow this line right here, what is that red line going to do to the material right here? It's going to kind of like take it with it. You know, think about when a semi drives by. It's pulling the air behind it, and if you're standing next to it, what do you feel? You feel that air pushing you with it. So this little current is actually going to drag material up with it. So what we get is another cycle, but it gets flipped. So we get these cycles that look like this. Because as that red one's coming up, it's going to force the other material next to it to also go up. Well, what is the blue going to do? And the blue is now also going to drag other material down behind it. And so what we get are these alternating cycles. And then when you really start thinking about this, then you start understanding how we get divergent boundaries versus convergent boundaries.
So you're saying like where you have the first, not the first two, but the third and second
Yeah.
one. So when they go, it's the crust, it's just going to keep going until the trench, and then it's going to go down, and then
Yep.
next.
Exactly. And so,
Would it make the trench deeper enough?
yes. Now this is kind of an important one because we can see that done on this. Hopefully this loads. You can see this played out here. That as these currents come up together, it literally takes the ocean plate and pulls it apart. So what kind of boundary do we get there? That's divergent boundary. And that's where we have the upwelling. Where the material is condensing and pulled back down into the core, what do we have going on there? That's convergent. So that's again where we get our mountains that form. So notice again, our continent to continent, we get very large mountains that form.
So does it switch every once in a while?
Yeah, well, that's a good question. What do you mean by switch?
Well, like how Pangea split apart,
Yeah.
and then it created all this, now they're colliding together. Aren't they going to come back together anyway?
Yeah, eventually.
It's because it just keeps moving, and then doesn't or whatever you're showing, switch its direction on where it's going.
Ooh,
Because
Brandon, that's pretty insightful.
it's got to run out sometime.
Yeah.
Pushing.
They can't keep just going in the same direction forever. And you're right. These convection cycles change their direction all the time. And when I say all the time, I do mean all the geologic time. So it might not happen within a human's lifetime, but it happens very rapidly in geologic time. So, and actually, Brandon, what we're going to do, we'll talk about that at the very end of class today. Okay? We're going to talk about how that affects things. Okay? Now, we understand that the heat is released from the core, and that heat is trying to escape through the crust. But really, these things moving on their own isn't really enough energy to split an entire tectonic plate. It's just not enough energy. So it needs a little bit of extra help. And one of the first things to think about is what starts the convection cycles. What starts that stuff on this circular path? Nope. It's actually something we call ridge push and slab pull. Okay? It's the very fact that with the slab being pushed underneath, think about what's going on there. That slab being pulled inward, as it goes down, it's dragging this material with it, and that's what starts your cycle. So you guys can see that the white cycle right here, that's that convection cycle that starts. And then on this side, it's not, when it does that, it's actually dragging the material in that direction, and therefore we get another circle that starts to form going in that direction. So this is actually, it's the slab pull that starts the convection cycles. And then you kind of see then that as this is going, pushing up, over here, this upward movement also will drag that cycle. So we get the divergent boundaries there. So this is what geologists think is actually the driving force behind plate tectonics. So this is kind of a new concept. Originally we thought it was just the convection cycles, but when we look at it, it's really getting towards the idea of slab pull. And this kind of makes sense. If I set this here, and I let go of it, what's going to happen? Why?
Because the bottom half
The bottom half is heavy. So it's literally going to pull all of that with it. Does that make sense? Okay? It's the same concept with the tectonic plates. The slab, the part that's being subducted, is so heavy, it's literally pulling the plate with it. Does that make sense? Are we making sense of this? Or I have no idea. Okay, I think we are. Good.
What happens if like the cycles get too close together? Can they like if they're both going opposite ways, or like would it mess them up at all?
I don't know. And that could be one of the, these cycles could run out, they could degenerate, and that might explain why we get new cycles that pop up somewhere else. Okay? One of the things I want to point out is right here. What do you notice about the thickness of the crust at the trench versus at the ridge? It's very thin at the ridge. Think about taking a big block of Play-Doh and you start stretching it. What happens to the center? It gets very thin, right? You pulled it nice and tall, it gets nice and thin. And then that's why that magma isn't able to seep up through there, because it's a very thin crust. There's a very thin layer on top. And it does break, which is how we get the ridges. That is the breaking point of the plate. Okay? So that's the idea. Now, as this stuff is being created, it falls down the ridge. That's what we call ridge push. That the material, as new material is being created, the old material gets pushed down toward the trench. Does that make sense?
Is that what we should write?
Yep.
Old material is pushed down.
Old material is getting pushed down toward the trench. So that's why we call this ridge push and slab pull. It's a complete mechanism. One does not exist without the other. The slab pull allows for the new material to seep up through the ridge, and the new material forces the old material down and out towards the trench. Okay, so that's what we really think is the driving force behind plate tectonics.
Slab pole is
Yep. Slab pole is where you have the subduction of the plate, and that's a large, massive plate, so it's pulling it all the way down. Okay, and then the last thing I want to talk about with you guys today, this is kind of what Brandon brought up. That was for you.
Oh.
Are these three questions? These are three questions that geologists are considering, but they just haven't gotten answers for this. You know, are they permanent? Do the cycles keep going forever? Well, at some point, you know, think about the Mississippi River, right? We said that was an old divergent plate boundary, but we are not diverging continuously, are we? So we can clearly see that those convection cycles have broken down underneath.
We said it was because it's still getting pushed.
We all, yeah. So I mean, you can actually break down those currents, and they will change. Not only that, they will shift their direction.
So at one time you say that the Mississippi River was
Yeah,
that pretty much mean
exactly. Now, along that lines, do the convection currents shift over time? Think about this. Think about the original orientation of the North American plate. It was actually like here we sit now. All right, it was kind of rotated like this and coming into Africa, right? So what did it do? It twisted itself up and then moved away. That's bidirectional. It has to twist and then move away. So that tells us that our convection currents, which drive that diversion, are shifting the directions that they're making these divergences. Okay. The other thing we're not really sure about is whether or not this is all cause and effect or just correlation. Does the slab pole create the convection currents that then drive the plates? Or is it simply that they coexist? One does not necessarily cause the other. They just simply are as they are today. Okay, a perfect example of that is a lot of people want to say that the Industrial Revolution is a cause and effect of today's global climate change. Well, you can see there's a lot of data that suggests that there's a connection, but we have not proven that there is a cause and effect with that. There's a very strong correlation, but there is not a cause and effect. Okay, so that's one of those key things that, for you guys as young scientists, that's one of the things I want you guys to constantly think about. When somebody's trying to say, this created this problem. No, is it really cause and effect? Or is it that they are simply correlated together? Do they coexist? Or did one create the other? Does one event cause another event to occur? That's cause and effect. And that's one of those things that as young people growing up, you need to learn how to differentiate between the two. Because a lot of people don't, and then they use that to convince you that you need to believe the same way they do. And so that's one of those life skills you need to learn. Yes? Okay, sure. All right, and that actually ends our lesson.